This is an atom. It consists of protons, neutrons, and electrons. Neutrons don't do much, but protons and electrons do. Protons are electronically positive, while electrons are electronically negative. In all elements, the numbers of protons and electrons are equal. Electrons in the outermost region of atoms are called valence electrons. But here comes the problem. Some elements aren't happy with their valence electrons. They either don't want to have any of them, or they want to have 8, the most number an atom can have. Let's take an example of the sodium atom and the chloride atom. The sodium atom has 1 valence electron, and chloride has 7. So, when they meet, sodium atoms transfer their only valence electron to chloride. There are more protons in the sodium atom than valence electrons, so they are positively charged, forming sodium ions. Chloride is the opposite. Since every ion attracts oppositely charged ions, they form orderly 3-dimensional arrangements called crystals. They're so strong that they all have high melting points. Covalent bonds are another thing. Atoms don't give or take away valence electrons. Instead, they share them. For example, an oxygen atom has 6 valence electrons and wants to get another 2. So it shares them with another. That's how oxygen forms. Covalent bonds can be different depending on the number of electrons shared. In some cases, valence electrons are pulled unequally in covalent bonds, forming a polar bond. Oppositely, valence electrons pulled equally form a nonpolar bond. Polar bond and nonpolar bonds are the reason why molecules have different properties. Now, let's talk about periodic trends. Major periodic trends have 5 things: atomic radius, electronegativity, ionization energy, electron affinity, and metallic character. Atomic radius comes in first. It's the amount of space that an atom has. It decreases from left to right as you go along with the period because the number of protons and electrons increases along it. Because protons have more effects than one electron. Thus, electrons are pulled towards the nucleus, resulting in a smaller radius. Atomic radius increases from top to bottom within a group. Electronegativity is another thing. While atoms attract and bind with electrons, electronegativity shows their attractiveness. As we all know, elements are more likely to attract electrons on the right side of the periodic table instead of the left. Thus, an atom's electronegativity increases from left to right, from the top to bottom down a group. It decreases because the atomic number increases down a group, so there's an increased distance between the valence electrons and nucleus, or a greater nuclear radius. Noble gases don't apply to this because they have complete valence shells. It also does not apply to lessonides or actinides because they don't follow these rules. Ionization energy is the energy the atom takes to remove an electron from another neutral gas atom. Ionization energy is the same as electronegativity because ionization energy increases from left to right on the periodic table. The lower the energy is, the more possible for atoms to become a cation, a positively charged ion. The higher the energy is, the more unlikely to become a cation. Generally, elements on the right side of the periodic table has higher ionization energy because they have more valence electrons. On the left side of the periodic table, they have lower ionization energies because of their willingness to lose electrons and become cations. Electron affinity is the ability of an atom to accept an electron. Unlike electronegativity, electron affinity is a quantitative measurement of energy change. It occurs when an electron is added to a neutral gas form. The more negative the electron affinity value, the higher an electron's affinity for electron. Electron affinity also increases from left to right, from bottom to top because of the decreasing atomic radius. And we have metallic characters, the last trend. It's how readily when an atom loses electrons. The metallic character increases from right to left because valence electrons will be separated from the nucleus more easily. It also arises from the top of a group to the bottom because of the increasing atomic size.